All right, today we're going to look at lesson 40, which is on simplifying radical expressions. Simplifying radical expressions. Okay, so we'll talk about a couple of things. One thing, just simplifying radicals in general, which is a review of something that you've done in the past. And then we're also going to look at radical expressions that have addition or subtraction or multiplication in them and how you can simplify radical expressions when you have those operations. But first we're just going to kind of start out with a general discussion. All right, so suppose that you had an equation like x squared equals 16. Now we know that in order to solve an equation like that, you'd have to take the square root of both sides, and the thing that we use to represent the square root is a radical, right? So and when I take the square root, I would get the values of x could be plus or minus the square root of 16. Okay. So there are two square roots, right? There's a positive one and a negative one. There's two square roots. So the solutions to this equation are like x equals the positive square root of 16, which we usually just write the square root of 16. When it's positive, we don't put the plus in front of it. And the other solution is x equals negative the square root of 16. Okay. So this one is called the principal root, or the principal square root, I guess I'll say. Okay, so the principal one is the positive one, and then this one is the secondary square root. There's two square roots, so one of them is principal, one of them is secondary. Okay, and so when we see an expression like this, the square root of 16, then we go, oh, well, the square root of 16, that equals 4. And we're not going to put plus or minus 4. We already know when we see this that there's no negative in front of it, so this must mean the principal square root. That's 4. This one, on the other hand, when we see x is equal to negative the square root of 16, we know that's the negative square root of 16, so that's the negative 4. Okay. So we would never write something, if I see something like this, the square root of 25, that means the principal root of means the principal square root of 25. So we would never say something like the square root of 25 equals plus or minus 5. That doesn't make any sense. There's only one principal root, that is positive. We would never write that. Okay. We would write the square root of 25 equals 5. If we wanted the secondary root, then we would write negative square root of 25. That would be negative 5. Okay. So don't confuse like solving an equation and oh, I know that there's two roots, so I'm going to write both of them. Okay, with thinking that if I have the square root of 25 that you're going to say plus or minus 25. That's an abusive notation, and that's not how it should be written. Okay, so now that we know that, that's square roots, but we can do lots of other roots besides square roots. You can take any root, and so in general, we want to define the nth root. Okay, so the nth root. So if we were to take some number, let's just call it a, and raise it to the nth power, and then when I did that, the answer was b, then we would say that a is an nth root of b. Okay, because we took a and we multiplied it by itself n times to get b. So that's called an nth root. If we multiplied a by itself twice, that's like a second root, or we call that a square root. If we were to take a and multiply it by itself 3 times, it's like a third or a cubic root. Okay, and then at some point we just say 4th root, 5th root, 6th root. We stop kind of giving them special names. Okay, so for example, we could have like this. We could have this. We could have this. Okay, so this is the square root of 32 when this is what the number that's written here. Okay, so let me write this up here. So we write the nth root of b equals a. This is called the index of the root. Okay. So when we don't write an index like this, when there's no index, so that no index implies 2. Okay. So if I don't see anything, I know that's a square root. We use that so often that we don't bother putting the index. If it's a less common root, like a cube root or a fifth root, cube root we have a 3 as the index, fifth root we have 5 as an index. So suppose that we wanted to simplify these radicals. Okay, and we know how to do it with 32. You know, imagine what you normally do. You take 32 and you factor it. So 32 is 2 times 2 times 2 times 2 times 2. Okay, right. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Right, so that's equivalent to 32. And so if I want to simplify the radical, I can look and say, okay, well, I can look for groups of 2. Okay, and I see a group of 2. Because I know, like just considering this, I know what the square root of 4 is. It's 2. So I can pull this 2 outside. Okay. And I know what the square root of this 4 is. It's 2. So I can take that one outside. Okay, now this one, I don't know what the square root of 2 is, so I just have to leave that one under the radical. So this one would be 4 square root of 2. Okay. When we simplify radicals with other indices, the logic is the same. So if I'm trying to do the cube root of 2 times 2 times 2 times 2 times 2, I'm not going to look for groups of 2 because my index isn't 2. Right? I know the square root of 2, but I'm not trying to find square roots of here. I'm trying to find cube roots. So I'll need to look for the cube roots. I will have to look for a group of 3. Okay. Now the cube root of 8 is 2 because 2 times 2 times 2 is 8. So that group of 3, I know what the cube root of that is, and I can take it out of the radical. Now there's only 2 of these. I don't know the cube root of 4, so I have to leave that 4 under the radical. Okay, so this would simplify to 2 cube root of 4. Let's say I wanted to do the fifth root of 32. Again, I would factor 32 into 2 times 2 times 2 times 2 times 2. This time I'm looking for fifth roots, so I need to look for groups of 5. 1, 2, 3, 4, 5. I have a group of 5 here. And so I can bring the 2 out. There's nothing left under the radical. And so the fifth root of 32 is 2. Okay. So you're very familiar with this process of simplifying radicals. You just have to look for groups of whatever the index is. So when it's 2, you look for groups of 2. When it's 3, you look for groups of 3, etc. Okay, so that's, let's just maybe try a couple more examples of these. So let's say that I wanted to simplify this radical, 60x cubed y to the 6th. Okay, so this is the square root. Okay, so I'm going to be looking for groups of 2. So let's see, 60 is 4 times 15, or 2 times 2 times 3 times 5. Okay. And now I know that I'm going to be looking for groups of 2. So what I'm going to do with these is try to put them into 2 equal groups as much as I can. Now with x cubed, I can't really put them exactly into 2 equal groups. So I'm just going to write them all out, all 3 of them. Okay. Now with y to the 6th, I can divide that into 2 equal groups. I could have y cubed and y cubed. Okay. So now when I'm looking for groups of 2, I have 2 2's, I have 2 x's, I have 2 y cubes. So I can bring all of those outside of the radical. I'll have the 2 outside, I'll have an x outside, and I'll have a y cubed outside. And anything I can't put in a group of 2 has to stay under the radical. So I still have 15 here, and I still have an x. So that would be 2xy cubed times the square root of 15x. Let's try another one of these. So I'll just do another. So let's say I had a 63 x to the 7th, y to the 12th. Okay, so 63 is 9 times 7, or 3 times 3 times 7. Okay, and then this x to the 7th, I can't divide it exactly in half. Okay, half of it is like 3 or 4, right? So pick the smaller of those. I could have 2 groups of 3. Okay, that would only give me 6 of them, and I'd need 1 more to make 7. So try to make it as equal as you can, and then you might have to have a leftover one if you have an odd number. And then when you've got y to the 12th, I can divide that exactly in half into 2 groups. So I can have a y to the 6th and another y to the 6th. So when I'm looking for groups of 2, I have 2 3s, 2 x cubes, and 2 y to the 6ths. So that will simplify. I can bring the 3 out. I can bring the x cubed out. I can bring the y 6th out. But I have to leave the 7 and the x under the radical. Okay. All right, so that's how we would simplify radicals. Hopefully you're familiar with this. I mean, you've done it mostly with just specifically with numbers and maybe not with variables before, but the principles are the same as what you've always done with the numbers. We're just adding variables to that. Okay, so now that we have remembered how to simplify radicals, something that we might want to do with them are multiply them to form radical expressions. So there's a product rule for multiplying radicals. Okay, and the product rule says that if I have an nth root of a and I multiply that by an nth root of b, an nth root of b, okay, this is n, then I can, as long as these indices are the same, this is an n and this is an n, I will get the nth root of a times b. Okay. So this is an n, this is an n. Sorry, I was thinking about what I was about to say and I made them different. Okay, so those are both the same. Okay, so one thing to note is that if I have an nth root, an mth root, and an nth root, and these are different numbers, okay, so if m and m are not the same number, okay, this cannot be simplified. So don't try to multiply a square root and a cube root together and put it into one. You can't do that. You can't simplify that. The only time that you can write it as a single radical is if the indices are the same. So here the indices must be the same. So those indices must match. Okay, so let's look at some examples. Suppose we wanted to do the square root of 2 times the square root of 30. Okay, the first thing we should ask ourselves is, do the indices match? Yes, they do. Index 2, index 2. Great. So I can multiply those. So that will be the square root of 2 times 30. Now, if I want to simplify that, then I know that I'm going to need to factor everything. So, okay, we've got 2, and then 30 is what? 6 times 5. 6 is 2 times 3, so that's going to be 2 times 3 times 5. All right, there's my 2, and there's my 30. And now I see I've got a group of 2 2s, so this will simplify to 2 square root of 15. Okay. Let's try a cube root. So let's say I had the cube root of 15, and I want to multiply that by the cube root of 25. Okay. So the first thing I would ask myself is, do the indices match? 3 and 3. Yes, they're both the same index, so I can multiply them and put them under a single radical. So I'd have my 15 times 25 under there. Now, if I want to see if I can simplify that, I should factor. I am in algebra class after all. So 15 is 3 times 5, and 25 is 5 times 5. All right. I'm simplifying a cube root, so I have to look for groups of 3. I've got 3 5s here. So this will simplify to 5 cube root of 3. Okay. And finally, let's say I wanted to do the square root of 10 times the cube root of 15. The first thing I would ask myself is, do the indices match? Well, this one, there's no index here, so that's a 2. This one's 3. The indices don't match. I can't do anything with it. Okay, this is already simplified. This is in its simplest form. This cannot be further simplified. That's as simple as it gets. Okay. So that is our multiplication or our product rule. Okay, so the other thing that we might want to do with radicals is add or subtract them. And we know that subtraction is really just addition and subtract and disguise. So it's a single rule here that we're going to look. So this is the addition. Of course, this applies to subtraction as well. Okay, and so you can only add or subtract like radicals. Okay, and this is very similar to like terms. You'll see what I mean when we do some examples. Okay, so like radicals means they have to have the same index and the same radicand. That's the number under the radical. Okay, so because it's very similar to the like terms, let's show the parallelism here. So let's say, okay, so let's say I had x minus 2x squared plus 3x squared minus 4x or something like that. Okay, so for like terms, we have to have the same variables with the same exponents, right? So that's what a like term is. So you have to have the same variables with same exponents. And so we'd look here, okay, well this is a variable x with an implied exponent of 1. Are there any other terms that have just an x with an implied exponent of 1? Yes, this one. So we would call these like terms. This one has x, but its exponent is 2. It's not like this one because it has an exponent of 1. But it is like this one because this one also has an exponent of 2. So these are like terms, right? And so if we wanted to simplify this, we know we can only add or subtract like terms. We can't combine anything else, right? And so when I would do this, I'll probably put the x squared. So I'll have an x squared first because I have 3 x squareds and I take away 2 of them. I'll be left with 1 x squared. And if I have an x and I take away 4, I'll have negative 3 x's. So that's how that simplifies. So very similar idea with like radicals. So just like with like terms, let's say we had a square root of 3 minus 2 square root of 5 plus 4 square root of 5 minus 6 square root of 3. Okay. So now I'm looking for like radicals. Like radicals have to have the same index and the same radicand. Okay, so this has an index of 2 and a radicand of 3. This has an index of 2, but a different radicand. So these are not like terms. Again, not like terms, but this one has an index of 2 and a radicand of 3. These are like radicals. So these ones would be like radicals. Okay. Similarly, okay, I've got an index of 2 and a radicand of 5, an index of 2, a radicand of 5. These would be like radicals. Okay. And as long as they're like radicals, I can combine them. So if I were to simplify this, I have a square root of 3, and I take away 6 square roots of 3, I'm going to end up with negative 5 square roots of 3. Okay. If I have negative 2 square roots of 5, and I add 4 more, I'll now have positive 2 square roots of 5. Okay. So you can see that it's very, very similar to adding like terms, except we have to do the same kind of idea with like radicals. Okay, so let's putting this all together. Let's say we have various radical expressions, and we want to take all these ideas and use them to simplify. Okay, so let's say I have the square root of 8 plus the square root of 18 plus the square root of 24 plus the square root of 50. Now, upon, just a quick inspection, you might say, oh, there's nothing we can do to simplify this because none of these are like radicals. Sure, they all have an index of 2, but the radicands are all different, so can't do anything. Okay, well, the thing is, we have to simplify each of the individual radicals first, and then check and see if we have any like radicals. But these are not in their each radical is not in its simplest form. So we would have to simplify this one. Okay, 8 is 2 times 2 times 2. So this simplifies to 2 square root of 2. 18, that's 2 times 9, or 2 times 3 times 3, right? So we've got 2 3s. This is a 3 square root of 2. 24, let's see, that's 3 times 4, no, that's 12, and then times 2, so that's going to be 2 times 12, which is 3 times 4. Okay, so we've got 2 of those, so we can bring out the 2. We'll have a square root of 6 in there. Okay, and then this one, we've got 2 times 25, so 2 times 5 times 5. We've got a pair of 5, so I can bring the 5 out and have a square root of 2. Okay. Now, once we've simplified the radicals, we see, oh, we actually do have some like radicals, right? We have a square root of 2, a square root of 2, another square root of 2. Now this 2 square root of 6 does not have any like radicals, but these 3 are like, so we can combine them. So if I have 2 square root of 2's and I add 3 more, I now have 5 square root of 2's, add another 5 square root of 2's, I'll have 10 of them. So 10 square root of 2, and then plus the 2 square root of 6. Those now can't be combined. I can't simplify it any further. Okay, let's try one that has some variables in it. So let's say I had 4 square root of 12x squared plus 2 square root of 18x squared minus 3 square root of 50x squared plus the square root of 27x squared. Okay. So once again, okay, if we're too hasty, we might say, oh no, like radicals, can't do anything, but we must simplify first. So this is going to be 4 times the square root, and 12 is 4 times 3, or 2 times 2 times 3, and x squared is x times x. This will be, let's see, 18 is 2 times 9, or 2 times 3 times 3, and this x squared is x times x. 50, we just did that one, that's 2 times 5 times 5, and our x squared is x times x. And let's see, 27, that's 3 times 9, or 3 times 3 times 3, and x times x. Okay, so we've got square roots, so we're looking for groups of 2, so we can take out a 2 and an x. So when we bring out a 2, we'll have to multiply it by 4, that will be 8. Then we can bring out the x, but we'll still have a 3 left. Let's see, we've got a pair of 3's and a pair of x's. So we can bring out the 3, we'll have 3 times 2, which is 6. Bring out the x. 2 doesn't have a friend, so we got to leave him in there. Okay, on this one we have a pair of 5s and a pair of x's. When we bring the 5 out, 3 times 5 is 15, so that's negative 15. Bring out the x, leave the 2. And then finally we got a pair of 3's and a pair of x's. We can bring out the 3, can bring out the x, gotta leave the 3. Okay. So looking for like radicals, we've got this square root of 3 and this square root of 3. Okay, and then we'll have to look at the terms in front of them. Could we add these? Yes, we can. So if we have 8x of them and we add 3x of them, we'll have 11x. So we'll have 11x square root of 3's. Now these are like radicals. Okay. If we had 6x square roots of 2 and we took away 15x square roots of 2, we'd have negative 9x square roots of 2. Okay. All right, let's try one with cube roots. Here, let me get a new piece of paper. Okay, let's try this one. Let's say we had 2 cube roots of 16 plus 5 cube roots of 54 minus the cube root of 24 plus 3 cube roots of 128. Okay. So 16 is 2 times 2 times 2 times 2. That's like 4 times 4, right? Let's see. 54 is like 9 times 6, so 9 is 3 times 3, 6 is 3 times 2. All right, 24, that's like 6 times 4, 6 is 3 times 2, 4 is 2 times 2. And then 128, that's 64 times 2, 64 is 8 times 8. 8 is 2 times 2 times 2. The other 8 is 2 times 2 times 2. All right, so that's everything is factored. All right, we're doing cube roots, so we got to look for groups of 3. There's 3 2's, so we can bring that out. 2 times 2 is 4. And then we'll still have a cube root of 2. Okay, looking for groups of 3, we have 3 3's, so we can bring that out. 5 times 3 is 15, and we'll have the cube root of 2 left. Looking for groups of 3, we've got 3 2's, so we can bring that 2 out, and we'll still be left with the cube root of 3. And then looking for groups of 3, we've got a group of 3 here, and another group of 3 here. Okay, so when we bring out the first 2, 3 times 2 is 6. Bring out the second 2, 6 times 2 is 12. So we'll have 12 out here and still have that 2 that doesn't have any friends left under there. Okay, so like radicals, okay, we've got a cube root of 2, cube root of 2, cube root of 2, this cube root of 3. We're not going to be able to combine that with anything. Okay, so 4 plus 4 of these cube roots of 2 plus 15 will be 19. 19, add 12 more, we'll have 31 cube roots of 2. Okay, and then we don't have a like radical, so just minus 2 cube root of 3. All right, so those are various examples of simplifying radicals, and then adding and subtracting radicals. And remember, we should always simplify them before we make hasty decisions about whether they can or cannot be simplified. So make sure you get them into their simplest form before you start looking for like radicals.